Hello everybody. In this screencast, we are going to do a very interesting programming assignment. What we want to tell you through this screencast is how do you pick a real world problem and model it with the help of Python and Networkx. So we will be using both Python as well as Networkx in this screencast so that you can learn how to put both of them together and use. The real world problem which we will be picking is the network of cities. So we have a lot of cities in India. So we represent every city as a node, and then we have edges between these cities which are the roads connecting these cities. So we'll be assuming that between two cities there is one road, though there can be many. So we pick one, and then there might be a traveling time associated with each of the road. So you can visualize this as a network where nodes are the cities and edges are the roads connecting them. Some roads might be good, some roads might be bad, some roads can be congested, some roads can be free, and so on, which affect their traveling time. If you would have heard of the traveling salesman problem, you would be very easily able to imagine it. But it's otherwise also it's easy to imagine. So you have a network where there are cities and there are roads connecting these cities. So we'll be making this network with the help of Python and Networkx. We'll be visualizing it and we will be looking at various properties of this network. So let's get started. How do we do it? So what we are going to do is we are going to model the road network of India. Let's say India's cities. Okay, let's say we are going to model the road network of cities in India. So, as I have already told you what is the graph here. So let me first save this file. I have this folder screencast here. Let's say I save it with the name cities.py. For better even, let's say it model.py. So I have a model.py here. So let's see how do we model the road network. Okay. So let me first make a graph. So for making a graph, I need the Networkx package which needs to be imported. So we import Networkx as annex. Okay. So now we can use it. And we are going to take the graph as undirected. So we are going to assume that if there is a road between, let's say, Delhi to Mumbai, assume there is a road between Delhi and Mumbai, so it will take you equal time to go from Delhi to Mumbai and from Mumbai to Delhi. So hence we can have one edge, and the graph is undirected. So here we are going to make an undirected graph. G equals to nx dot graph. So when you write G equals to nx dot graph, it automatically creates an undirected graph for you. So let me tell you, there is a possibility of making directed graphs as well. So a simple code by which you can make a directed graph is nx.digraph. So if you use this command nx.digraph, there will be a directed network created. So it will be a directed graph here. But we are working with undirected graph. So I'll just comment this statement here. Okay. So we have made a graph G equals to nx.graph here. Now I have a graph. What I want to do is I want to add nodes to this graph, and every node should represent a city. So let us have an array of city here. Let's say city set, which is a set of cities from where we'll be choosing the cities. Okay. So I have a file here. Just I looked at Wikipedia and looked at some of the cities. So let's pick some cities from here. Let's pick all these cities. Control C, and let's say I put all these cities here. So these city names are strings. So one thing, when you are working with strings, you have to put these in quotes. So I'll put all of these in quotes. This will take a small time. I'll put all of these in quotes. Okay, so I have a set of cities here. So this is the set of cities. Now we want to create nodes in this graph, which should be these cities. So what we can do is, so we have a list here. We have to create cities, and the values of these cities should be from this list. So what we can simply do is, for each in city set, so if you would have gone through the module of using lists in Python, you would know that each is an iterator which will go through each of the elements of this list city set one by one. So for each in city set, what we want to do is, we want to add a node to this network. So we do g.add node, which is the command for adding node, and each. So we have these nodes added in the network. Now I want to visualize this network. We know that the package which is used for visualization, Undirected.draw, and for visualizing we need to import one more module here. Do import matplotlib.pyplot as plt. So what we can do here is Undirected.draw and then plt.show. Okay, so let's run this and let's see how does it work. So I open a terminal window here. So I'll mainly okay, we'll be using this terminal window here. So we are in the home. So we'll first go to this folder whose name was screencast. Okay, and then we'll run this python model.py. Some problem. So it says that the draw function takes at least one argument. So when we are Undirected.draw, we need to pass the graph here, which is g. Okay, again run it. Okay, so you can see here that we have a network created where each node is one city in this network. So we have added 1 2 3 4 5 7 8 cities we have added in this network. Perfect. So now we have a graph in which there are cities. There are 8 cities. Our next aim is to add edges between these cities, or roads between these cities, and every road should have a traveling cost associated with it. So this traveling cost we represent it by the weight of an edge. So we have to add edges here. So how do we add edges is the question. So we are going to add these edges randomly for now. How do we do that? So first of all, we have a, let's say, array costs. What we are going to do is, we are going to add some random edges in this network, and each edge will have a random value, random weight, random traveling cost, which will be picked from this list cost. So we want to first of all populate this list cost so that we can pick values from here. So what do we do? Let's say I'll add some 20 values here. Let's say starting from 100. So what I will be doing, while value is less than or equals to 2000, posts.append, and I'll do here value, and then value equals to value plus 1. So it will iterate like it will iterate like 100, 200, 300, 400. It will keep appending the value and it will go up to 2000. Let's see what this array looks like, and we'll just comment these two things. Okay, so this is how our array will look like. It has values from 100 to 2000. That is our array posts. Okay, so now we are going to add edges in this network. Assume that we want to add, so there are 8 cities. So for now, let's add some 16 edges. So we are going to add 16 edges to this network. Okay, so count is in each. Okay, so we are going to add 16 edges to this network. So till when your code should run? While, so for looking at the number of edges, you have this code g dot number of edges is less than 16. Okay, so this code will keep running till the number of edges in your network becomes 16. What you are going to do is, we have to choose two nodes randomly. So for choosing a node randomly, we need to import the function random. So we import the function random here, import random, so that we can use it. Okay, we come down, so we choose city1 equals to, so if you want to choose a value from a list randomly, so we have random dot choice, and we have a function g.nodes. So g.nodes gives you a set which has all the nodes in this network. So we are going to choose one of these nodes randomly, that is our city 1, and then we choose city 2, which is again random.choice, and again g.nodes. Now one thing to note here is these two cities should not be same. So only if C1 is not equals to C2, we are going to move next. What we are going to do is, we are going to choose a weight for the edge. So let's say weight, which is the traveling cost. Now this is nothing but random.choice, again a random function, and it will pick a random value from our array costs. Okay. Also, okay, so the one condition for creating an edge is both of these cities should not be equal, and the second condition is there should not be an edge which is already present between these two nodes. So for that we have a function and g dot has underscore edge. It tells you whether there is an edge between two nodes c1 comma c2. So has at c1 comma c2 should be equal to 0. There should be no edge between them. So in that case we will choose a weight here, w equals to random dot choice costs, and then we will add an edge in this network, g dot add edge, and we add edge from c1 comma c2, and the weight of this edge is w, which was a random number. So this code keeps running, this loop keeps running till we have 16 edges in the network. Okay, again I want to see this network, so I use annex.draw g and then plt.show. Okay, let's execute this and see. So you see here, so the edges are not very clear, some of the edges are overlapping here. So what we can do for this is, we can change the layout of this graph. So one of the layout that we can use is the spectral layout. So for using the spectral layout, we have a command. So let's say we want to choose a layout, pose equals to annex dot draw underscore spectral. Pass this POS here. Let's see how does it work. Okay, so the command here is annex dot, and we want a spectral layout, so we use it spectral underscore layout. We pass our graph G here, and while drawing it we use annex dot draw POS. Okay, so let us now visualize this graph, python model.py. So when you see it, it looks better than before. Okay, so we can also use some other layouts. Let's try to use a spring layout. Very nice, and circular layout might look better here. Let's try the circular layout. Okay, so this one looks perfect. So we have drawn this graph in the circular layout and it looks nice here. So there are 8 cities and they have 16 edges, and each of this edge has some edge weight associated with it. So you might want to look at these edge weights as well. So for labeling these edges with their edge weights, so here we have drawn the network X, and let us draw their edge weights also here. So we have this command annex.draw underscore network X underscore edge underscore labels, and then we pass here G comma POS. Okay, So let us see how does it work, and then let me just clear it. Then again we run python model.py. So you see here, so it has to be tried some number of times, and when you draw it in a circular layout, it turns out to be a pretty nice configuration here, though it's not very clear, but yeah, still you can see the edge weights here. Okay, so now we have a network which has some 8 nodes and 16 edges, and we have visualized this network as well. So we have drawn these edges randomly. So we have drawn 16 edges randomly between random pair of nodes. So now we have created the network with the cities and the roads. What we are next interested in is looking at the paths between these cities and the cost of traveling across that paths as well. So first let's look at the path between these cities. We want to look at the path length between every two possible pair of cities, and by path length what I mean here is note the sum of the weights of the path, just to see whether I can reach from city A to city B or not. So first of all, let us see that whether even this graph is connected or not, because if the graph is connected, it means that I can reach from every city to every other city and so on. So let us look at whether this graph is connected or not. So we'll just okay, print. So we have a command annex dot is connected G, which tells us whether this graph is connected or not. So let's see, just clear it. See that the graph is connected. It means that there is path between every two pair of nodes. So this okay, so what we want is we want to delete some edges, let's say, so that we do not have some paths between some pair of cities. So what we can do for that is, let us reduce the number of edges here from 16 to, let's say that we'll just have 10 edges in this network, and let's see what happens in that case. So if we have 10 edges, again the graph is connected. So it's actually interesting, you see, it's a network on 8 nodes and we have put just 10 edges. Even then this network is turning out to be connected. Let's reduce it to 5, let's say, and then when we put the number of edges to be 5, it turns out that the network is not connected. So it is false, a network is not connected. So let's look at this network as well. Okay, so you see the network here, right? So this, okay, there is this one city which is not, these which are not connected at all to any of these cities. Okay, so let's take one more example. So it can be like this and so on. Okay, so what is now we want to see, assume that we want to see path between which city's path exists and between which city's path does not exist. So what we do for that is, for each possible pair of cities, we see that whether there is a path between them or not. So we have a loop here for, let's say, u in g dot nodes, and then for v in g dot nodes, what do you do is print u v comma, and then we have a function here annex dot has underscore path, which tells us whether there is a path between these cities or not. We pass here g u comma v. Okay, so what I'll do it, I'll put this code before drawing the network so that we can see both the things simultaneously. And let's see now, just clear. So you see here, so this is our network, and Perfect. So this is our network here, and these are the paths. So it tells you for every possible pair of cities. So Hyderabad to Hyderabad is obviously path is there. Hyderabad to Chennai there is a path. Hyderabad to Delhi there is no path. So you see here from, let's say, Hyderabad to Pune, and we look from, let's say, Hyderabad to Pune. I'm very sorry, we have mixed Pune and Jaipur. So let's say it's Pune. So from Hyderabad to Pune, if we look that there is a path. So you can go from Hyderabad to Surat, and from Surat you can go to Pune. Okay, so this is a fictitious network. The connections might not be really this way. So it's just a fictitious. So don't look at it in real world that how come Hyderabad is connecting to Surat and then to Pune and so on. So okay, there is a path from this node Hyderabad to a node here. So we have listed it for every two pair of nodes. So you can look at, then from Chennai we can go to Hyderabad through, let's say, Bangalore. So again you see here, if you look the connection between, let's say, Chennai and Hyderabad, which is somewhere here, yeah, so it turns out to be true. And from Delhi, you see, from Delhi you can't go anywhere according to this network, so every value from Delhi turns out to be false and so on. Okay, just close it. Okay, it's done here. Now next what we want to look at is what are the shortest paths in this network. So we have some really cool functions in Networkx, so which are the basic standard algorithms implemented in Networkx, with the help of which you can see the path length or the traveling cost between two cities. So let me quickly show you some of these. So these are here. So you can see that these are the functions. So we have one function Dijkstra underscore path, which tells you the shortest path from source to target, and then underscore path length, which so given two nodes it tells you the length of that shortest path. Then single source Dijkstra path, where you give one source node and it gives you the all the shortest paths and so on. So we are going to use some of these functions and see how do they work in our network. So for working with this network, what we'll be going to do is, let's now switch a little bit to the interactive IPython. Okay. So what we are going to do is, we are going to turn to IPython, and then we are going to import Networkx as nx. Okay, import matplotlib.py. Perfect. So we are going to define some functions here. So let's make this code a little bit organized and make some functions from this. So let me in a function define create network, and let's say this function takes as input the set of cities, the array costs, and let's say number of edges which you want to create. Okay, so what all we will have this inside this function is, this term will come here. So g equals to nx.graph, and then for each in city set we are going to add an edge. So this particular code comes here. For each in city set we are going to add a node, and then what else? Okay, so this entire code will be shifted there. So this is when we were adding 5 nodes in this network. So we'll basically change this code. First of all, let's paste it here. Okay, so while g dot number of edges is less than, so we are adding num edges number of edges. So let me make it num edges here. Okay, and then perfect, and this will return you this graph G, which you can then visualize. Okay. And let's comment rest of our code further. Meantime, we commented rest of the code. So everything is mostly commented here. Everything is commented except for this function here. So this function is simply what it is doing, taking a city set, taking a array costs, taking the number of edges and creating a graph. Okay, so how do we do it here? So we are going to import this model here. So there it shows an error at line 12. Okay, so this is the for loop. So here you have to always take care of the indentation. And let's import model, and we have imported it. So to call this function, we should have some parameters, which are the city set, the cost and the number of edges. So let us define these parameters here. So I'll just copy paste the set of cities here. So I have a array here for the city set. We can also see this array here. So we have this city set, and then we want this costs to be here. So I'll just take this code, just paste it here. Let us look at the array cost. So we have this array costs here, and let's say I'm going to add some 10 edges. So let us add 10 edges. So we are going to call this function, and the function name is create_network. So what we are going to do is model dot create_network, and here we are going to pass the 3 parameters. So what are our parameters? One is the cost, city set. Yeah, so we are going to pass here city_set, and then say costs, and then we are going to add 10 edges in this network. So we have to collect this network in a variable. Let's say this variable is g, so g equals to this. So let's try looking at this graph. So let's say nx.draw g, and then plt.show. So we can see this network here, and it is connected. Okay, so we have a graph here, and every edge has a weight associated with it here. So now what we want to see is, we want to see the implementation of the shortest path functions. So let's one by one take the shortest path functions and see how do they work. So let's look at the first one here. So if you give it the graph and the source and the target, it will return you the shortest path. Okay, let us try. So let's look at a graph once more. So let's choose 2 nodes here. Let's say we choose Delhi and Kolkata. So let's say our node number 1 U is Delhi, and our second node is Kolkata. Okay. Now what we are going to do is, we are going to look at the shortest path between these 2 nodes. So what we are going to print is nx dot Dijkstra, and then it was the underscore path, and then you pass your network here, and the first node and the second node. Yeah, so you get your shortest path here. So from Delhi you go to Pune, and then from Pune you can go to Kolkata. Similarly, we can actually see it between every. Let's choose some 2 different cities. Let's choose Bangalore and Surat. So let's write it down, Bangalore, and let's say, yeah. So you see here that Bangalore and Surat are connected with Kolkata, and this is the shortest path. Perfect. Next function is for path length, where you do not want to see the path but you want to see the path length. So we know here, so we do a path length here and you. Okay, so this path length is returning here 2500. So the cost associated with going from Bangalore to Surat is 2500. Why is it turning out to be 2500? Let's see. So let's say that if you want to go from Bangalore to Kolkata, you can go it in 1700, and let's say that you want to go from Kolkata to Surat. So we can write it this way because it's an undirected graph. It's 800. When you sum both of these, it turns out to be 2500. So you go from Bangalore to Kolkata, which costs you 1700, and then Kolkata to Surat costs you 800, and the sum turns out to be 2500. Perfect. Then we have the single source Dijkstra path. So I will not go into each of these. So what you can do here is you just give a source node and it will tell you the shortest path from the source node to every other node in the network. Similarly, you can look at its path length, and then you have a all pairs Dijkstra path which will compute the shortest path between all the nodes in the network, and then here also you can look at the path length as well. Okay, I'll just exit. Okay, coming back to our code. Now what we will do is we are going to plot a curve. Okay, and let's see what our curve is going to do. Okay, so let us set first of all this code straight. So we have this city set here, we have this course here, and okay, we don't need these functions, and this is for let's uncomment it. Perfect. And here we had to call this function create underscore network, and where we were passing the city set, and then our costs, and then the number of edges which we want to have. So let's put very less number of edges, 4. Okay. Now one question, what is going to be the path length if there is no connection between two nodes? So we are interested in looking at, so we have looked at various different Dijkstra pathfinding functions. What does this function return if there is no path between a pair of nodes? For example, assume that initially we had 0 edges in this network. So there is no path between any two nodes in this network since there is no edge. So what happens if I print a Dijkstra pathfinding function? In this case, let's try to do it. So let's choose two nodes, let's say Delhi and Bangalore. So what I'm going to do is I'm going to print annex dot Dijkstra and then path and then length, path length between say Delhi and Bangalore. Okay, just call my function here. Okay, so it has given a type error that we should have given 3 arguments. So what's missing here is graph G. Okay, now let's run it. So you see here that there is an exception. So the code has returned an exception, and the exception is node Delhi not reachable from Bangalore. So we see that how do we catch these exceptions in the network? Assume that I do not want to return an exception here, rather I want my code to show me a 0 here, that the path length from Delhi to Bangalore not 0, it is infinity, right? So my answer should be infinity. Or since our graph is very small, let's represent infinity here by a big number, let's say 10,000. So we are representing infinity with 10,000, though it's not a very well accepted notion, but we are just using it in this code for the sake of convenience. So what we do this in this case is something called exception handling, which is very simple. So let's look at, we just need to import a module sys here. After importing this package, what do? I just put this statement inside a try block. So what my try block does, it gets this path length L as annexed of Dijkstra path length G Delhi Bangalore, and in case there is an error, so we looked at an error here, and this exception handling, and this error was a key error. We see here. Okay, so we accept in the case of an exception. What does we do it? Let's say we print error. Let's see how this piece of code works. So you see here that there was an exception, and this exception was because there was no path, and we have printed here error. So what we can do is, instead of printing here error, we can set this L to be 10,000, or let's say even 100,000, and then we print here path length equals to L. And let's see here, when we run this code again, we get here a path length of 100,000. So what this is doing, whenever there is no path between two nodes, it will return 100,000, which is a very big number according to our code, according to our network story. So it's a very small network. Now what we want to do is, we want to see a plot, and what will this plot do? There will be two cities in our network, and we'll be adding random edges, and as we add random edges, we are interested to see how this path length decreases. So let's write a small piece of code for this. So what we are going to do is, initially we have this graph here G. So what we are going to do is, while we are going to do is, we have calculated here L, right, and L was here 10,000. What we want L to become is, let's say 1, because the minimum path length between two nodes is 1 till they become directly connected. So till while your L, it is greater than 1. Okay, so what you do here is, you add an edge randomly. So I call a function here add random edge, right? Add a random edge in G. So how this function is going to work is, let's create a function here, define add random edge G. And so we have the city set here, but we want to pass here the coast, because every node should have a coast. Okay, one thing here, this path length is actually equal to the coast here, right? So this is equal to a traveling coast. So we can't say it's less than 1. So we'll just run this code for some number of steps, because path length is never going to be 1 here, because our path length is a traveling coast here. So what we'll go is, for I in range 1 to 10, we'll see for the 10 timestamps what happens here. Okay, and let's make it a little bit larger number. Okay, so add random edge G coasts. So what it is going to do is, what exactly we have done above. So what we have done is, right, we have taken two random nodes, and if there was no edge between them, we have chosen a edge and added between them. So exactly the same thing we are going to do here. So essentially we are just copy pasting this code. Okay, Okay, so what we are doing is we choose two nodes randomly, and if there is no edge between these two nodes, we'll add an edge with their weight being equals to W. So okay, this is done here. Add random edge G dot posts, and after that what we are going to do is, so since we have to plot this graph over 10 timestamps, we need two arrays. One is for x-axis, one is for y-axis. 11. So x-axis is our time, which is essentially I here, or let's represent it as t. So we will have an array x, and we'll have an array y. X will be initially having the value 0, right, because it's the 0th timestamp, and y will initially having the value L, which is a very big number. So what we are going to do here now is x dot append t, that is the time, and in y what we have to append again is the Dijkstra path length. So it's again going to be a try function. So we are going to try. What we are going to try is, let's say stick it L equals to nx dot extra, and then path length and G comma Delhi comma Bangalore, right? And then we are going to accept an error. So this exception is in case where there is no path between the two. So here we are going to set L equals to, it remains the same, which is a big number, 1 2 3 4 5. So there are 7 zeros. Perfect. And then what we are going to do is y dot append L, and then we want to plot this. So for plotting this we have plt dot plot, and we have x and then y, and we can actually give our axis name. So let's say that plt dot x label, that's our x-axis, is our time, and plt dot y label, y-axis, is our, let's say, traveling cost, and then we have a title, let's say change in traveling cost as more roads are added in the network. So let's try to see. Okay, so clear here. Okay, so there's a small spelling mistake here, let's correct it. Okay, there have been some problem. It is printed our path length. Okay, so here we have made some small changes to this code. So the value of L, we have just changed it to be 10,000. We can just to so that the plot looks nice, and it shouldn't be way too high, but it's still higher on the part that we have very less edge costs, which are just 2500 or something. And then the statement y dot append L has been shifted. So instead of adding at the end, we added inside the loop, because we have this break statement inside the try block which is needed. So if this break statement is there and we put y dot append at the end, so the value is not appended. So we append the values to our array y in between the try block and the added block, and then we have a plt dot show here, which was initially missing, so it is required to show us the plot. So let's see here. So when we execute this code, so we see here something. So the initial cost was 10,000. So this was the cost which is actually infinity for us, right? So initially Delhi and Bangalore were not connected, and after some time steps, so after some 11th time step, so the random edges are keep creating in the network, and after some 11th time step, this cost drops and comes to 3000. So it becomes connected. So there was just a small code. So it might not be very clear to you. So if you have any doubt regarding this, you can leave it in the discussion forums and we can discuss it further. So this was just a basic plotting function which we can do using Python and Networkx. Just an example for that.